Good morning, my dear students. In last session, already we discussed vector joining 2 points and some important note points. So, in this session also, we have to discuss some collinear condition. Okay, here, so they will give one question. They will give two vectors. We have to show that collinear. Okay, suppose here a bar is equal to a1 I cap plus a2 j cap plus a3 k cap. B bar is equal to b1 I cap plus b2 j cap plus b3 k cap. Therefore, b bar is equal to lambda of a bar. That means what is b bar now? b1 I cap plus b2 j cap plus b3 k cap is equal to lambda of a bar is a1 I cap plus a2 j cap plus a3 k cap, equating ijk coefficients. That is b1 is equal to lambda a1, b2 is equal to lambda a2, b3 is equal to lambda a3. That means b1 divided by a1 is equal to lambda, b2 divided by a2 is equal to lambda, b3 is equal to b3 divided by a3 is equal to lambda. That means b1 by b1 divided by a1 is equal to b2 divided by a2 is equal to b3 divided by a3 is equal to lambda. So this is lambda condition. Okay, this is collinear condition. A bar is equal to a1. Suppose if any two vectors are given, you have to show that those two vectors are collinear. So that means you have to find b1 by a1 is equal to b2 by a2 is equal to b3 by a3. It will be same value. That is a bar is equal to a1 I cap plus a2 j cap plus a3 k cap. B bar is equal to b1 I cap plus b2 j cap plus b3 k cap. So now b bar is equal to lambda a bar. That is b bar is b1 I cap plus b2 j cap plus b3 k cap. So is equal to lambda a1 I plus a2 j plus a3 k. b1 is equal to lambda a1, b2 is equal to lambda a2, b3 is equal to lambda a3. So b1 divided by a1 is equal to lambda, b2 divided by a2 is equal to lambda, b3 divided by a3 is equal to lambda. So that is b1 divided by a1 is equal to b2 divided by a2 is equal to b3 divided by a3 is equal to lambda. So this is collinear condition. So thank you everyone. Direction, next one is direction ratios. Here direction ratios and direction cosines. Direction ratios and direction cosines are, okay. So direction ratios means here, suppose I will take a bar, that is a1 I cap plus a2 j cap plus a3 k cap. So here a1, a2, a3 are direction ratios. Okay. So direction cosines, okay. Direction ratios and direction cosines. So direction ratios are components of a vector. Okay, that means a bar is equal to a1i plus a2j plus a3k. Here a1, a2, a3 are direction ratios. Next, direction cosines. So direction cosines means now, so this is x-axis, this is y-axis, this is z-axis. So this is line segment. Okay. So now from line segment to, okay, from line segment to x-axis is that is alpha, from line segment to from y-axis to, this is line segment P, from y-axis to line segment is that is beta. Next, from line segment to z-axis is that is gamma. Okay. Now here alpha, this is one angle, this is one angle, this is one angle. Alpha, beta, gamma are direction angles. Direction angles. So now here we should use cos alpha, comma, cos beta, comma, cos gamma. So these are called cosines. Okay. So here alpha, beta, gamma are direction angles. Okay. So this is, you should use cosine. That's why direction cosines. Direction cosines or direction cosine angles. Okay. Cos alpha can denoted as L. L is equal to cos alpha. M is equal to cos beta. N is equal to cos gamma. So here L, M, N are direction cosines. So direction cosines represented by DCS. Okay. Direction ratios denoted by DRS. DRS means direction ratios. DCS means direction cosines. Okay. So here, suppose here when you take, when you given direction ratios, when you given direction ratios, in direction ratios we should find direction cosines. Okay. So now when angles is given, find here, they will raise two questions. When vector is given, find the direction cosines. When angles is given, find the direction cosines. When angles is given, the direction cosines are cos alpha, cos beta, cos gamma. When vector is given, suppose a bar is equal to a1i plus a2j plus a3k. So like this they given. The direction cosines are, that is L is equal to plus or minus a divided by square root of a square plus b square plus c square. M is equal to minus or plus b divided by square root of a square plus b square plus c square. So n is equal to plus or minus c divided by square root of a square plus b square plus c square. Okay. So I mean, here don't confuse direction ratios and direction cosines. Direction ratios means, so vector components are called direction ratios. Suppose a bar is equal to a1 I cap plus a2 j cap plus a3 k cap. Here a1, a2, a3 are direction ratios. Okay. Suppose a bar is equal to some I cap plus 2j cap plus 3k cap is given. Okay na? So the direction ratios are, the I component is what? 1. J component is what? 2. K component is what? 3. Okay na? Now 1, 2, 3 are direction ratios. When like this given, we have to find direction cosines. So that time we should use this formula. L is equal to plus or minus a divided by square root of a square plus b square plus c square. So M is equal to minus or plus b divided by square root of a square plus b square plus c square. So N is equal to plus or minus c divided by square root of a square plus b square plus c square. When angles is given, find the next question. Find the direction cosines. So when angle 45 degree, 60 degree, 30 degree, they will give. So that time we should use this formula. L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. So this is about direction ratios and direction cosines, and briefly we have to study in 3D geometry. So this direction ratios and direction cosines will continue on 3D geometry. Here some problems is there in your NCERT second exercise. So based on that I discuss so few points of direction ratios and direction cosines. We can we'll study briefly about direction ratios and direction cosines. Continue of this chapter is 3D geometry. Thank you everyone.